So what the ASM Materials Camp is an introduction to materials, science and engineering for high school students, mainly grades 10 and 11. It's a one-day affair. It's held at the Worcester Polytechnic Institute. We can't teach much materials science and engineering in one day. What we can do is give the students a glimpse into the world of materials science and engineering. We can also tell them a little bit about careers, because it's very hard for students at high school to understand what a professional working in a company does all day. The camp is organized by the 4 local chapters of ASM, the Boston chapter, the Worcester chapter, the Rhode Island chapter and the Northern New England chapter. Of course, actually it's individuals who organize the camp. People from all those chapters and some volunteers from WPI get together in the fall each year to form a committee, plan and organize the camp, which is always held in May. During the day, the students will visit 8 modules. At each module, a certain aspect of material science and engineering will be explained, and the students will have a chance to meet a professional and 1 or 2 grad students and ask them questions. We really hope students will ask a lot of questions because that's how they get their best information. The day was kicked off with introductory remarks by Professor Diran Apelian, head of the Metal Processing Unit at Worcester Polytechnic Institute.
Some of the things that you will be facing by year 2040, if not before. We could actually start today. Let me ask you a question. Do you think the gas prices are going to go up over time or going to go down? Which way? How many say going to go up? Okay, good thinking. The consumption rate in the world is going like crazy. So can we continue the same way we are? No, we got to figure out a different way. You look at transportation. In terms of mobility, taking people from one place to the other, housing issues, all of the basic human needs.
The students were divided into 8 groups and rotated between the 8 modules. At the heat treating and mechanical properties module, the way that mechanical properties of materials can be changed by thermal processing was demonstrated. Students learned that tools and components can be strengthened, hardened or softened through heat treatment to suit the needs of the manufacturer. By heating steel to different temperatures and cooling at different rates, it can be made hard, soft, ductile or brittle. Students manipulated test pieces to feel firsthand the nature of brittleness and plasticity in heat-treated steel. At the Materials ID module, we play a materials game show with students and work to identify 14 elements through their visual appearance, density, electrical resistivity and magnetism. The idea is that although engineers use sophisticated equipment, a lot of knowledge can be gained from simple experiments. Also, it's important to rely on your instincts in engineering and really think about what you're testing when you experiment with something. Hopefully the students realize that they know more about engineering and materials than they thought. Prizes were awarded to the members of the highest scoring team. At the casting module, the students were given an overview of the casting process, including metals that are typically cast, mold design, the importance of castings and the applications of castings. Each student was provided a sand mold and tools to carve out a shape of their choice inside the mold cavity. Zinc alloy was then poured into the molds. After it solidified, the mold material and excess metal was removed and the students took away the cleaned castings as souvenirs. The ceramics and glass module first describes what makes these materials different and then showcases how these materials apply to the real world. The station consists of 3 subsections. A curiosity table with a collection of ceramic pieces illustrating different engineering functions, such as refractory space shuttle tile and non-corrosive ceramic scissors. The second substation uses an electromagnet to charge magnets. Each student gets to charge their own magnet and take it away with them. The last section demonstrates thermal shock, where the students get to heat glass rods with a propane torch. The rods have a range of thermal coefficients, so some break and some don't. At the microscopy module, students experience stereomicroscopy and optical micrography of samples of different materials. Emphasizing that the microstructure of a material determines its observable properties, the mentors gave evidence about the investigations, qualification or failure analysis for which the samples were prepared. Students were able to print their favorite micrographs and take them home. At the physical vapor deposition module, students learned about PVD, otherwise known as sputtering, and some of its many applications. They watched the sputtering process as glass slides with their fingerprints were coated with gold, and they got to take each their gold slide home. The intent of the polymer technology module was to provide students with insight into the diverse world of plastic and elastomer materials that are in common use today. Following a brief introduction to the major classifications of polymers, along with example applications, students at the learning station were split into two groups. While one group initially explored several of the many types of plastics available, along with their possible uses, the other group learned about the manufacturing process known as plastic injection molding. Having a benchtop injection molder available provided the students with a hands-on experience of molding their own screwdriver. Most students are into music, but they never think about sound, what makes a speaker work, or makes one speaker better than another. These concepts are demonstrated in the Music, Materials and Speakers module by examining materials used to make and reproduce sound. Students receive a cutaway speaker and are introduced to magnetic, electrical, mechanical and acoustic disciplines in a familiar and well-loved application. At the Shape Memory Materials module, the shape memory alloys are demonstrated. Shape memory materials have a unique shape memory property that allows them to be deformed and returned to their original shape when heated. To illustrate this effect, students are asked to deform springs made from either stainless steel or nitinol, which is a shape memory alloy. As the students watched the nitinol spring magically return to its original shape, they immediately became engaged and began asking how and why questions. After learning the science behind these materials, students are allowed to play with a variety of different shape memory alloys, and when they leave the station, they're given a shape memory spring to take home. After attending the final station, the students returned to the meeting room for closing remarks by Professor Diana Lados of WPI.
Historians decided that this period of time in history have to be named by the materials that people use to make their tools and pots and things like that. So materials all along time, they were driving the evolution of the society essentially, and this is the truth also nowadays. They are helping the evolution of the society, and we are both dependent on the materials, and we have to realize that also we are limited by the materials, and it's our responsibility as scientists and engineers in this field to be able to develop new materials and push the technology, because by developing materials we are going to be pushing the technology ahead.
The ASM Materials Camp was an unqualified success, thanks to our many generous sponsors.